Next important chapter is aldehydes and ketones. Again a biggest chapter, just like haloalkanes and haloarenes. Aldehydes and ketones. Aldehydes are having CHO group as functional group, which may be written in this way: C double bond OH as functional group. It is present at the end of the chain. At the end of the chain. So RCHO is any aldehyde. Any aldehyde. So CHO group is functional group of aldehyde. One valence is available, so we can attach one alkyl group. RCHO means any aldehyde. CHO, that is C double bond OH, valency of carbon is 4, valency of carbon is 4, 1, 2, 3, 4. Valency of oxygen is 2, valency of hydrogen is 1. So one valence is available. So this CHO group is always present at the end of the chain. From this side you can attach any alkyl group, simple or substituted alkyl group, aliphatic or aromatic alkyl group. You can attach any alkyl group. Hydrogen can also be attached. If hydrogen is attached to CHO, then this is called as formaldehyde. If methyl group is attached, then this is called as acetaldehyde. Acetaldehyde. If ethyl group is attached, CH3, CH2, CHO, ethyl group is attached. Then this is propanaldehyde. Propanaldehyde. If propyl group is attached, CH3, CH2, CH2, CHO, then this is butyraldehyde, butyraldehyde, and so on. So any alkyl group can be attached, hydrogen can also be attached. If hydrogen is attached, then this is formaldehyde, methyl group is attached, this is acetaldehyde, ethyl group is attached, this is propanaldehyde, and propyl group is attached, this is butyraldehyde. These are common names, these are common names of aldehydes. Now these common names are derived from the name of acid. These aldehydes on oxidation gives acids. We already studied in the chapter of alcohols. So aldehyde group can be converted into acid group on oxidation. CHO group is converted to COH. So this formaldehyde corresponding acid is SCOH, and CH3CHO corresponding acid is CH3COH. Here corresponding acid is CH3CH2COH, and here corresponding acid is CH3CH2CH2COH, and so on. All these aldehydes on oxidation gives these acids, and this acid, this SCOH is called as formic acid. It is called as formic acid. This acid is called as acetic acid. Acetic acid. This acid is called as propionic acid. Propionic acid. And this is called as N-butyric acid. N-butyric acid. These are common names of acids. These are common names of acids. And we know that for common name there is no rule. Common names may be given from their original source, or maybe from number of carbon, or maybe from name of the scientist. So here This name formic acid is given from word formica. Formica is a Latin word. Formica meaning ant. चींटी में होता है, मूंगे में होता है. Therefore, it is called as formic acid. Acetic acid is found present in acetum. Acetic acid is from acetum. Acetum means vinegar. It is present in vinegar. Therefore, it is called as acetic acid. Propanic acid derived from propane, as it contains 3 carbon, propanic acid. Butyric acid is found to be present in butter. Therefore, it is called as butyric acid. So, these are common names of acid. Now, from the name of acid, this IC acid is replaced by word aldehyde, is replaced by IC is replaced by word aldehyde. So, that we are getting name of this aldehyde. So, this aldehyde, what is the corresponding acid? Formic acid. So, from formic remove IC, attach aldehyde, formaldehyde. This is corresponding acid is acetic acid. From acetic acid remove IC, attach word aldehyde. So, acetaldehyde. Propionic remove IC, attach aldehyde, propanaldehyde. Butyric remove IC, attach aldehyde, butyraldehyde, and so on. So, these are common names of aldehyde, and these common names are given from the name of corresponding acid, from the name of corresponding acid. From the name of corresponding acid, IC is replaced by word aldehyde. So, that we are getting common names. So, these are common names. For IP system, usual rules are followed. Select the longest chain, etc., etc. And E of the alkane is replaced by Al, because in aldehyde Al is the prefix. जो पहले लगता हो prefix, जो आखिरी में लगता हो suffix. So, here Al is the prefix. So, E of the alkane is replaced by Al. Now, select the longest chain of carbon. How many carbon? 1. 1 carbon means it is derivative of methane. From methane remove E, attach Al, methanol. Methanol, not methanol. Methanol is alcohol. OL is attached for alcohol. Al is attached for aldehyde. Slight difference is there. OL means alcohol. Al means aldehyde. Select the longest chain of carbon. How many carbon? 2 carbon. So, it is derived from ethane. Remove E, attach Al, ethanol. From ethane we are getting ethanol. 1, 2, 3 carbon, propane. So, propanol. 1, 2, 3, 4 butane. So, butanol. From pentane, pentanol. From hexane, hexanol, and so on. All these are aldehydes. These are IPC name of aldehyde. So, formaldehyde is also called as methanol. Acetaldehyde is also called as ethanol. Propanaldehyde is also called as propanol. Butyraldehyde is also called as butanol. देखो So that is about aldehydes. Now ketones. Ketones. Ketones are having C double bond O as functional group. This CO group, carbonyl group as functional group, and it is not present at the end of the chain. It is not present at the end of the chain. Aldehyde group is present at the end of the chain, but ketonic group does not present at the end of the chain. So RR C double bond O is any ketone where R and R dash, these are alkyl groups, may be same or may not be same. Means you can take same alkyl group or different alkyl group. If you take same alkyl group, then such ketones are called as simple ketones. If you take different alkyl group, then such ketones are called as mixed or unsymmetrical ketone, just like simple ether and mixed ether. They are also simple ketones and mixed ketones depending upon the alkyl group. And the alkyl group may be aliphatic or aromatic. So two alkyl groups are attached to C double bond O. If you take two methyl group, CH3 C double bond O, this is dimethyl ketone, which is popularly called as acetone. The famous name of this is acetone, popularly called as acetone. If you take one methyl group and one ethyl group, different alkyl groups, then E come first alphabetically, ethyl methyl ketone, ethyl methyl ketone. If we take two ethyl groups, C2H5O, and get attached to C double bond O. As there are two ethyl groups, this is diethyl ketone. So any alkyl group we can take. This is simple, and this is mixed ketone. Simple ketone and mixed ketone. If alkyl groups are same, simple ketone. If alkyl groups are different, mixed ketone. So common names are derived from the name of alkyl group which is present. Common names are given from the name of alkyl group which is present. देख लो. So common names of ketones are given from the name of alkyl group which is present, and for writing the name of alkyl group alphabetical order is used. For IPS system I will write the ketone in different way. I will write in a chain of carbon CH3 C double bond O CH3, one and the same thing, CH3 CH3 C double bond O, same CH3, then C double bond O, and then C2H5. I will open this carbon as CH2 CH3. Ethyl group I will open in this way, CH2 CH3. So that counting of carbon will be easy. Ethyl group I will write in this way, CH3 CH2 ethyl group, then C double bond O group, then again CH2 CH3 group, ethyl group. This is diethyl ketone, this is ethyl methyl ketone, and this is dimethyl ketone, same ketones. Now for IP system usual rules are followed. Usual rules are followed, select the longest chain, etc., etc. And E of the alkane is replaced by ONE, because in ketone ONE is the suffix. ONE is the suffix. In aldehyde E is replaced by Al prefix. Al is the prefix in aldehyde. So here E is replaced by ONE. Now select the longest chain, 1, 2, 3. How many carbon? 3. 3 carbon means propane. From propane remove E, attach ONE, propanone. This is propanone. Which propanone? 2 propanone. Functional group is at carton number 2. But we need not write the number because there is only one propanone. There is no other propanone. So we need not write the number. Actually this is 2 propanone. Here 1, 2, 3, 4. 4 means butane, remove E, attach ONE, butanone. Which butanone? 2 butanone. So 2 butanone. So 2 propanone or simply propanone or 2 butanone. 1, 2, 3, 4, 5. Pentane is replaced by ONE. Functional group is at carton number 3. So 3 pentanone. There is 2 pentanone also, CH3 C double bond O and propyl group, CH2 CH2 CH3. So 1 methyl group, 1 propyl group, methyl propyl ketone. What is the IPC name? Select the longest chain, 1, 2, 3, 4, 5. 5 carbon means pentane is replaced by ONE, pentanone. Which pentanone? 2 pentanone. So 2 pentanone and 3 pentanone, they are isomers of each other. 3 pentanone and 2 pentanone, they are isomers of each other. Position of functional group is different here, position isomers. Here functional group is at carton number 3, here functional group is at carton number 2. So position isomers, 3 pentanone, 2 pentanone. देख लो. So common names and IPC name. Common names are given from the name of alkyl group which is present. For IP system, usual rules are followed, select the longest chain, etc., etc. And lastly, E of the alkane is replaced by ONE. So aldehyde RC double bond O H RCHO and ketone R C double bond O R. This is aldehyde. This is ketone. CHO is functional group of aldehyde. R CHO means any aldehyde. RR C double bond O means any ketone. Is there any similarity in aldehydes and ketones? Yes. What is the similarity? This portion is same. R C double bond O, this portion is same. Only difference is due to H and R. Only difference is due to H and R. Here H is attached to carbonyl group, one alkyl group, and one H is attached to carbonyl group. Here two alkyls are attached to carbonyl group. So we can say that carbonyl group is common. Carbonyl group is functional group. So they are called as carbonyl compounds. Carbonyl compound. So we are studying aldehydes and ketones in the same chapter. Why? Because they are having same functional group. Carbonyl group is common in both the cases. C double bond O, C double bond O is same. What is the difference? To this carbonyl group, one alkyl group and one hydrogen is attached, and here two alkyls are attached. So what is the difference? H and R, that is the only difference. And as there is hydrogen attached to this carbonyl group, it can give this hydrogen, so it can act as reducing agent. Aldehyde can act as reducing agent. Ketone does not act as reducing agent, it does not give free hydrogen. Here free hydrogen atom is there. So that is the difference. And therefore, when we shall study chemical test for aldehydes and ketones, aldehyde gives test with failing solution, tolerance reagent, Skipp's reagent because of this hydrogen. Ketone does not give this test, because in that test aldehyde is acting as reducing agent. Ketone does not act as reducing agent because there is no hydrogen. aldehyde में यहाँ हाइड्रोजन होता है और इसलिए ये रिड्यूसिंग एजेंट का काम करता है. यहाँ पर हाइड्रोजन नहीं होता, ये रिड्यूसिंग एजेंट का काम नहीं करता. तो दैट इज द ओनली डिफरेंस. यहाँ H है, यहाँ R है. अदरवाइज देयर फंक्शनल ग्रुप इज सेम, and that is why we are studying aldehydes and ketones together. Their methods of preparation properties are similar. Their methods of preparation properties are similar. भाई बहन का रिश्ता है दोनों का. एक ही चैप्टर में हम दोनों को पढ़ रहे हैं, क्योंकि फंक्शनल ग्रुप सेम है. और फंक्शनल ग्रुप सेम है इसलिए प्रिपरेशन समान रहेंगी, प्रॉपर्टीज भी समान रहेंगी, सब कुछ समान रहेगा. थोड़ा सा फर्क रहेगा यहाँ पर केमिकल टेस्ट के लिए. ये रिड्यूसिंग एजेंट का काम करेंगे, ये नहीं करेंगे. दैट इज द ओनली डिफरेंस. Otherwise they are same. So aldehydes and ketones, they are isomers of each other also. They are isomers of each other also. So if you want to write isomerism, you have to write both aldehyde as well as ketone. If you are given the molecular formula, any molecular formula, then you have to write the isomers, aldehydes as well as ketones. So these are carbonyl compound, these are commonly called as carbonyl. So aldehydes are carbonyl compound, ketones are also carbonyl compound. So how to prepare these aldehydes and ketones, that we shall study tomorrow. देखो लिखिए.